Hey everyone, I'm here with Brooks Townsend, and my name is Bailey Hayes. We're both engineers working at Cosmonic, and today Brooks is going to give a walkthrough on how to take code from your laptop straight to the cloud, but in a very cool way. Brooks, you wanna kick it off?
Yeah. So the feature that I'm actually going to be showing you today is called Super Constellations. And that's kind of a loaded and fun, like spacey word, but it may not mean a lot to you now. So I'd love to kind of talk through that and talk through what that really means when we're talking about like making the development experience and like the changing architecture requirements easier and less painful in cloud native application development today. So really this is all based on our underlying mission at Cosmonic slash, the open source project that underpins a lot of this, which is Wasm Cloud, which is bringing joy back to distributed application development. So the kinds of things that interrupt your joy or make application development hard, there are a lot of things revolving around networking. I'm personally not a network engineer, so I find a lot of it to be frustrating around service discovery and auto failover and like just getting things working that I really feel like are a pain in application development. And it's part of one of the things that we try to make easier. And there are really two big categories of that I'm going to show today. And that is the transition from local development environment to production or to the cloud or to the edge or wherever really you're deploying. And the other category is when your cloud architecture or like your actual application architecture changes over time, actually making it so that you can change that in a flexible way without re-architecting or changing all of your code is difficult in a lot of systems today. And that's really part of what we want to make easier. So I'm going to go ahead and share. So I've got some controls that I will just fuddle with really quick. I'm going to share our docs on super constellations. Now, I mentioned this before, and to really understand what a super constellation is, you probably want to understand what a constellation is in the first place. This is a term that we use in Cosmonic to kind of encapsulate your managed, isolated network space. This is so that you can deploy your applications to Cosmonic, or with super constellations, the idea is anywhere without fuddling with setting up the underlying network or making sure that your pieces of compute can communicate with each other. And this is all kind of powered by NATS under the hood. NATS, if you haven't heard of it, not the DC baseball team. You can see their branding. They call themselves Connective Technology for edge and distributed systems. And at the very base level, like an example you may see is doing like pub sub or request reply networking. But in reality, there's so much under the hood that they offer around security, around, I mentioned auto discovery or self-healing networks. NATS does a lot of this under the hood with their platform, where pieces of compute that you connect into a NATS cluster, no matter where it actually is all automatically connected. There's no IP addresses, there's no DNS names. It all happens through the NATS server. And so I would highly recommend checking out this technology. It's an open source project powered by Synadia, is the company that employs a lot of the maintainers and developers. Really, it's a fantastic project, and a lot of the underpinnings of our network are NATS. But you, as a developer for Cosmonic or Wasm Cloud, likely won't interact with this directly until you get into doing your own pub sub or request reply type of networking. So the constellation, which is, as I said, your network space, is kind of a managed NATS installation. So we facilitate setting up the network and making sure that things can communicate back and forth. You bring your application components and just deploy them. And again, a super constellation is this idea that this doesn't have to live within the Cosmonic cloud or the Cosmonic infrastructure. This can be extended anywhere. So to give you an idea, I really like this diagram. I think it was our CTO, Kevin Hoffman, who put this together, that we have this network space in Cosmonic, and the connections to that are very flexible. You can have multiple different devices. You can have a developer workstation, like, I'm running this on my laptop. different clouds, your own data center, things like that. They can all be seamlessly connected as smaller components. Now, the neat part about this is that every single connection here that's, you can think of Cosmonic as the supercluster, and then each individual little thing as smaller connections are using NATS leaf nodes. And you don't need to know much about that underlying technology. The cool part is that all of the messages that you're passing back and forth will always stay local to the device until they need to route up to the Cosmonic cluster. So even if you're connecting up to Cosmonic, I just want to point out that that doesn't mean that all of your remote procedure calls, all of your functions are going to be making a network hop to the supercluster every time. So lots of talk and a little bit of pre-info. I really like to explain our network and some of our terminology, but I'd like to actually show you what this looks like in practice and what it looks like to run under the hood. It's a WASM Cloud host, but to use our tooling to run WebAssembly in your local environment that's connected to the Cosmonic network. So there are a couple things in this document, which looks like Bailey has already pinged in the stream chat. So feel free to follow along if you're feeling adventurous. The only thing that we actually need ahead of time is the Cosmo command line interface. And that is just hosted in a different section of our documentation. This is cosmonic.com/docs. So whether you're on Unix or on a Windows machine, we have a nice little one-liner install command. And I'm going to follow that. I actually uninstalled everything from my local and reset everything to net new so that what you see is what you get when you're following this. So running this one-liner, this is going to reach out to our central, grab the Cosmo command line interface, and then install it in a .cosmo directory locally. We also give some nice little examples for adding this to your path. I won't have to do this again since I already did it once. But running Cosmo, we can actually see some sweet ASCII terminal art, which, who doesn't love that? So the actual process to launch a host, and I said this before, but I'd rather define it. The host is a WASM Cloud host, which is just it's just a binary. So this is not launching anything in Docker. It's not launching up like a Kubernetes node or anything. Perfectly compatible with those things, but it's just a native binary that you can run. We can just run Cosmo up. And this is going to kick off a few processes. The first one is it's going to open up my browser screen, you'll see, to log me in. There's a secure method for authentication. We took a lot of inspiration from the ways that like the Netflix, the Hulus do it, where, it's really a seamless thing. You don't have to enter in passwords and two-factor and all that stuff. And then it's going to download NATS and WASM Cloud and launch that locally connected to Cosmonic. So running Cosmo up, this is going to open up the Cosmonic in the browser window, and you can see that in the terminal, we're kind of waiting on, waiting on something actually coming through. So we can hit launch. This will log me in. I've already gone through kind of the Google Auth login here, and get me to authenticate my device. And if we check back in the terminal, we have kind of finished this process. WASM Cloud has been started, and this node actually just popped up. So you can see this kind of all connected. So this is Cosmonic. WASM Cloud, I've mentioned a few times, is kind of the open source underpinning of what Cosmonic does. WASM Cloud is an open source project. It's a CNCF sandbox application runtime. So it's all kind of donated to the CNCF at this point, but it's all about running WebAssembly from cloud to edge without any of the cruft of what we call non-functional requirements. So things like key value stores, message brokers, HTTP servers, things like that. Those are all abstracted in a way into what we call capabilities. And then you can kind of plug and play those at runtime so that when you're developing an application, it's a breeze. It's easy to get started. It's easy to maintain your applications, especially as so much of the code that we write is actually what we call non-functional requirements, like open source libraries, bringing in extra dependencies that you ultimately don't want to manage on your own as a part of your application. So what just happened? Great question. So a lot of different things happened in that small process where I ran Cosmo up. We downloaded NATS and Wasm Cloud and launched them on our local machine, and then connected that up into the Cosmonic infrastructure. You can see this is on app.cosmonic.com. This is our actual product. Which, by the way, is in developer preview. Anybody is actually able to go sign up for this at get.cosmonic.com and check it out for themselves, including what I'm showing you today, the Super Constellations. And so when you see this host pop up on your canvas, it means it's ready for things to be deployed on it. It's ready for any piece of WebAssembly compute to actually handle applications. And so I don't see anything in the chat quite yet, but I do have I have a couple things that I love to show. I mentioned the local development experience. So I'd like to take you through kind of a simple microservice type of application that I built, and love to make some changes to it and deploy it on Cosmonic. So opening up my little VS Code window, I actually built a fun application, and I can open up the README here, called WADICE. Sticking with a WebAssembly trope of sticking WA for like WASM on the front of it. It's a WASM Cloud WebAssembly module that rolls a D20 and then gives you the result of the die. And we actually use this at Cosmonic for a lot of our things, like in stand-up, to determine who goes first. It's really just a good bit of fun. But as you can see, this is a simple, fun idea that really shouldn't revolve around me, dealing with all these different paradigms and like building a container, deploying it to a Kubernetes cluster. We just want it to work. So taking a look at the code here, this actually should be pretty simple to grok, or to understand, even if you haven't seen Rust before, which is what this actor is written in. We have a single function called handle request. This WADICE WebAssembly module is written in terms of some common contracts. The first one being HTTP server. So we receive an HTTP request, and then we return a result of an HTTP response. Pretty generic representation of an HTTP server. I've got some fancy goodies like returning a favicon, so that when I run this in the browser, like I hit the HTTP endpoint, I can get a nice favicon back. But really the core of the application is using the D20 crate and creating a role, and then returning that result from the role by generating a random number, kind of as this little like dummy HTML web page. So this is all pretty fun. It's a simple application. And the process to build this is just you can either run make, which will build the actor, or you can use wash, which is the WebAssembly or the WASM Cloud shell, to build this actor. So this is just compiling using the native like Rust toolchain, and then signing it with some additional goodies. I mentioned capabilities earlier. So this specific WebAssembly module uses an HTTP server. It uses a number gen library for number gen capability to generate a random number, and then a logging capability just to make sure that I can, whenever somebody rolls a die, I can know about it. So now I've actually gone ahead and launched a Wasm Cloud host locally. And just like when you're doing local development with Wasm Cloud, you can navigate to localhost 4000 to open up the Wasm Cloud dashboard. And I can start this actor from a file. So let me go to this specific library, which is WADICE. Under build, let's see, you should be able to see that. Yeah, we have the single signed WebAssembly module. So that whole application that you just saw is 739 kilobytes, nice and small. So we can start this actor. The next step is filling in its runtime capabilities. So we'll start an HTTP server. We can find that from the, we'll actually just use this one that's kind of pre-filled in as the OCI reference. we'll use the Wasm Cloud HTTP server. And then the last step is kind of linking these two things together. This is so that they can communicate at runtime and really facilitates just the fact that, or something that I'm going to show you as we continue going on through this stream, which is these things don't have to all just run on local and can actually be really easily moved through different pieces, through different architectures and different clouds and everything. And all of it kind of works all the same. So the link is in, which one am I actually using? MAK. The link is in service of that. So I can take this Wasm Cloud actor. I can link it on the HTTP server and give it a port of 8080. So when I do this, if I go to localhost 8080, you can see that I rolled an 8 or 11 or 9. You know, I can keep refreshing until I did see a 20. So I won't go too far to get some 1. So very simple actor. This is returning, you know, rolling a D20. What I actually want to show now, which is kind of a lot of the pain past the initial POC phase in application development today, is what does this look like to actually take this from local development into the cloud? Like, how do we actually get this WebAssembly module to go, or how do we actually get this piece of compute, this application that I created, and run it somewhere else? And that causes a lot of friction today. So if I go back to the Cosmonic dashboard, you can see now on the what we call the logic view of this application, you can see my 2 application components laid out here. So I have Wadice, my actor or WebAssembly module, and my HTTP server. That's, you know, all of this is running locally. You can see on this single host. We like to call this for fun. We like to call this Stargate. This is all running on my local machine. So what does it look like to kind of transition this from local dev to production? Well, I'm glad you asked. What we can do is we can come and we can interact with this information the same in the Cosmonic UI as we can in the Wasm Cloud dashboard. So around links and capability providers like HTTP server. So I'm actually going to probably use the Cosmonic dashboard from here on out. I can take this link that's kind of linked them together, and I can terminate that link, and I can get rid of the local HTTP server. Now, this is kind of temporarily broken our application. It's not running anything locally anymore, but this is all in a good cause. So I have this one host that's running on local. I can actually use the Cosmonic infrastructure view to launch a host. This will actually run on Cosmonic's cloud, on Cosmonic's infrastructure. So this will persist even if I close my laptop or even if I throw my laptop out the window, no matter what scenario you can kind of dream up. And then I can use the logic view to create a new HTTP server. This one is compatible with Cosmonic's network. It actually runs on Cosmonic's network and allows you to open up a publicly accessible DNS name to it. We call that a wormhole. And I can run this on my Cosmonic managed host. So now this is a different HTTP server, but the same implementation of a contract. So even though I wasn't using this locally, everything will actually end up working just the same. So I can link this together the same way that I did it through the Wasm Cloud dashboard. And then the last step, I can use the Cosmonic UI to create a wormhole, or you can think of this kind of like an ingress point into your protected network. Now we have this URL, this wormhole called Bitter Paper 6783. If I click access, I can actually hit this, and I can actually put it. I can't put it in the stream chat. I'll see if I can send it to Bailey, our fearless moderator, for you all to check out. But you can actually hit this endpoint and roll a die. And since we have logging enabled, kind of the cool thing is if you hit this, at least it should. They may flow in here in just a moment. You can actually get your own rolls, right? So this is a lot just happened in that few seconds, and I don't want to gloss over it. we actually took our application that's running locally and we exposed it publicly with an endpoint. So that endpoint that you're hitting is actually sending messages to a WebAssembly module that's still running on my laptop and working all the same. So this is really cool. We are able to address a lot of things around the local development story where this kind of move is normally a huge pain. So the last step really here is to make it so that when I'm working with this, I don't want to just run this WebAssembly module locally. I want to run it in the cloud. I want to kind of transition this away from my local machine. And so what we can do is, we can set this up however we'd like. But if I go back and so I have this kind of all running on my local machine, but I've actually gone ahead and pushed this to a publicly accessible OCI compliant registry, which is GitHub CR. I can start this actor on my Cosmonic managed hosts, just like I did before, and I can link it together. And then let's see this one. I'm going to go ahead and open up a new wormhole just to make sure that everything kind of connects. Cool Bush 9479. Nice. So I'll send this one out too. You can actually hit this, and now everything is running on the Cosmonic managed host. So we've kind of pushed the actor out to different compute. I can run a copy of this on my local machine as well. So if oh, that's not going to work. I can run a copy of this on my local machine. And then so now, if I look at the view on my local, I have this Wadice WebAssembly module running, and then in Cosmonic, I have it running on both my local machine and in the Cosmonics cloud. Now this is really cool because anytime I hit this, wrong wormhole. Anytime I hit this, they're actually kind of semi-randomly round robining between the two. And so we're essentially load balancing between these two instances of the same application, even though they're running on different infrastructures. So, and then whenever I'm done with this, obviously on local, I can close my laptop. I can actually get rid of the local host entirely. So this Mac OS host, we can kind of terminate it out of existence. And I'll do that here through the UI for fun. And everything in the application will still continue to work all the same. This is all kind of in service of the self-forming, self-healing infrastructure that the constellation provides. Now, I've been talking for a little bit. I can take a little bit of a pause to maybe address any questions that have come up, because there's a lot of power that's happened in the past few minutes. I just took this app that was running on my local machine to the cloud and I was able to talk through it, and that is usually a heck of a feat to code and talk at the same time.
Yeah, for anybody listening, I asked Brooks to stream about an hour ago, so
Yeah.
that's how quickly he's able to get this demo up and running, which is really, really awesome. And it looks like we actually got a question in from the chat. I'm not displayed on the screen. So, you got to compliment Brooks. Nice demo. How would you automate this with some deployment, including some rollback?
Yeah, so that's a great question. So I'd love to actually show you kind of what the deployment process looked like for when I was deploying this actor, because I know that I said that I went ahead and kind of pre-baked the turkey on that one, and that's mostly in service of us not sitting here and waiting 3 minutes to watch Rust build. But the way that this kind of CI works, so that automating this deployment is just done through GitHub. So what happens is anytime I push a commit to this URL, it runs this, or to this repository, it runs this release action. And I don't want your eyes to glaze over for looking at YAML, so please bear with me for a second. All this does is runs that same build step that I did locally, and then creates a GitHub release and uploads that signed WebAssembly module to it. So you can see here that I have a few different tags, 012, 013, things like that. The second part of your question is actually even more fun. So in terms of like running this through with rollback and like upgrade story, the neat thing is actually kind of messed up when I was deploying this. I didn't remember my newest version is 0.1.3. So I'm pretty sure I deployed. Oh, maybe I got rid of it. I don't think so. Yeah. So what I did was I deployed, it's kind of small over there in the corner, but it's actually version 0.1.2. And that one, I did not include logging. So in the console, you saw that, oh, or maybe I did. Okay. Well, that was an older version that I thought may have not included logging. In order to actually upgrade this actor, we can just terminate it out of existence, type in the new version, and then run the new version of the actor. Everything actually automatically relinks together and traffic continues to flow to the new one, which again is really tiny, but over there is 0.1.3. And doing this automatically, these WebAssembly modules are 700 kilobytes. So hot swapping this, which can be done in the command line, so through CI, not just playing through this canvas, can be done pretty instantly without a lot of downtime. So I could actually terminate this actor. I could go back to version 1.0, which I know doesn't have logging in it. So if I go and I hit this act, it actually has a lot simpler of a UI. I forgot about that. So you can see kind of the old version of this. I can go and let me make sure I have the new one copied. None of this is being kind of persisted and logged. I can actually go and just delete this out of existence, launch the new one, and then it kind of like live refreshes. That's the cool thing about this underlying constellation network, is that everything just kind of self heals even when you kind of break your application. So you can see now my logs are being persisted again. Rolled the, oh hey, somebody else rolling? I didn't do that. Bailey, can you try it? Nice, nat 20. So yeah, I guess that was a long-winded way of answering the question, but automating deployment is really easy, even just through GitHub Actions. And automating like rollbacks, those kind of things can be done on the fly without having to mess with any configuration or recompiling your whole application. It's really simple to roll back to an older version.
Now, if I wanted to, would I be able to use something that has a declarative approach for this type of work? You're doing it through the UI. Do I have other ways of doing that?
Yeah, absolutely. Great question. So I'm going to take you onto the Wasm Cloud side really quick. Wasm Cloud, as I mentioned, is the open source organization. All of our things are proudly open source. We're not doing any kind of forking or anything on the Cosmonic side. We have a project called Wadum, which is the Wasm Cloud Application Deployment Manager with awesome logo to come with. So in terms of doing this in a declarative way, this application deployment manager kind of builds in a reconciliation loop into Wasm Cloud. Now, our whole goal is not to reinvent Kubernetes here. It's not a task that I don't think anybody should be up to. But our goal is to pick what people like about cloud native development today, and then improve upon the things they don't like. And things that many developers like is the ability to take a single manifest, YAML or JSON or, your thing of choice, and say, hey, I would like in the state of the universe it to be this manifest. Like, make it happen. I don't care how it gets there. And that is Wadum. So taking a look at one of these specs, I may actually go to the examples repository for Wasm Cloud real quick to take a look at this. We have an Echo actor, very similar to Wadice in terms of capabilities. It receives an HTTP request and returns an HTTP response. And we're actually making use of the OAM, the Open Application Manifest format to create this. So using cloud native technologies today, you can say that you want to run in a single Echo WebAssembly module. You can run a single HTTP server capability, and that they are linked together and listening on port 8082. So an additional thing you can do here is ensure that you have a certain number always running, which you can always fine tune based on your own usage. Or you can say, hey, I want to run one in this cloud, one in this other cloud, things like that. So this is all open source. The product version of this, so running in Cosmonic itself, is something that's coming soon. I mean, all the active development is in the open source, so it's easy to kind of see our roadmap as it's coming along. But we've been playing with this internally and really enjoyed it.
So, Brooks, do you mind doing some live coding for me really quick?
No, let's do it.
All right. So right now, I believe what's happening in the infrastructure is that this is all you took what you were building on your laptop and then you showed how you would deploy that to production. Do you mind backing it up to show back where you were in local development?
Yeah, sure. And you
So
may
let's
have
make a
seen,
change.
yeah, you may have seen me kind of do a little bit of you may have seen me do a little bit of a shuffle with this WebDice actor. Most of that is because of one thing that I didn't set up right before. The way that we address these WebAssembly modules is by a unique key, and that's based on their signing key. Things that Wasm Cloud generally takes care of for you, but I actually have different ones for deploying this actor and what's on my local machine right now. So I shuffle it just a little bit, but that's actually not usually something you need to worry about. So yeah, let me back it up a little bit. So I actually got rid of my local host. It's totally gone. So let me relaunch that. Run Cosmo up. And then we saw that pop into the canvas. So my dashboard should be coming up here live here in just a moment. There we go. I can launch this, the WebDice actor again from a file. And then let me make sure we can relink everything together. Again, this is just something that I'm shuffling because I didn't manage my signing keys properly. So let me create this wormhole. We have Springbrook for you, which is
Perfect.
apt. And so I'll send this out too, so that anybody can kind of hit this as we're going through the development process.
So what I want to understand is that when I hit this endpoint, Springbrook, am I hitting your local laptop, your MacBook Pro?
Yep, that is exactly what's happening. So when you make an HTTP request into Springbrook, that's kind of managed, and we expose a public HTTPS endpoint in Cosmonic. That request ends up making its way into the HTTP server that's running on Cosmonic's infrastructure. And then it sends a remote procedure call to this WebAssembly module that's running on my local machine.
So if you were just hacking away one day and you thought you had something kind of cool working, but maybe you aren't ready for PR or anything like that, but you wanted to show what you had, you could just send me a link and I would be able to check it out on your laptop where it's running.
Yeah, do you want to do that now?
Yeah, okay, let me give
Yeah,
it a
let's
shot.
do it.
I
So
will share a window, I guess.
yeah, can we do that kind of? Yeah, let's do it.
Okay, I'm gonna try. Sharing.
There we go.
You see mine? Let's see.
I think so. You rolled a 5, right?
Yeah, I did roll a 5. Let me try. I'm swapping around some views. Yeah, this one
Yeah.
might be the easiest to see both of us.
Okay.
So yeah, I'm gonna roll again, and I got oh man, I should
I
have
know. I
paused.
saw it.
I had a nat 20, but yeah, okay. So that's pretty neat. Is there any way you can prove to me that it's running on your MacBook?
I can actually. So if I go into my .cosmo directory, everything is kind of downloaded here. Let me squish a little bit. There we go. If I go into my .cosmo directory, everything is downloaded here. We actually have this log here, Wasm Cloud standard error. So if I tail this log file, and Bailey, would you kindly roll, please? Did you
All right.
roll a 15?
I did just roll 15. Boom. And so you did
Yeah.
that. Oh,
So I'm
somebody
just
else.
kind
That
of,
was not me. That was not me.
yeah, other people are rolling now, maybe Lachlan. But this is actually, kind of live tailing the local log is happening from this local Wasm Cloud actor. Guess that's most of, and now we're getting filled up. That's kind of proof that this is all coming in, which is fun. I'd love for you to try one thing, and we can kind of. I thought about a change that I may want to make. So if you can add a query string onto the end of your, I don't know how to show this. Add a query string onto the end of your URL, and you can actually change it to roll a dive of your own size. I think I'm using a signed 8-bit integer for this, so don't do anything huge. But like if you roll a d8, or you can do like question mark roll equals and then your query. So you could roll like a d8 and see that it doesn't go above a certain level, or a d30 or something to exceed 20. Yeah, go ahead and try that. Yeah, nice. You roll a 40.
What is up?
Nice.
Yeah, I did
Um,
a roll D42.
okay. Yeah, nice. That's pretty good. So, okay, so you can do that with the query string, but I actually don't love that. I kind of wish that I could make it so that I could just do like /1d30 instead of like the whole query string thing. Um, so I actually had a nice little I just wanted to be known that Bailey and I did not plan this. I just kind of I wanted to change this before. So this works out great. So let's change this. So right now what I'm doing is I'm parsing the query string, finding the role parameter, and then turning that into a role, or otherwise I'm just turning it into a D20. So let's change this and instead pull this rollout from the path. So the path is just like that. Anything that comes after the slash. Let's trim the ends. I think we can trim. Just get rid of all the matches. I just want to get rid of the starting slash to make sure that I'm not like trying to parse something weird. And then we want to turn this into, I want to make sure that if we leave this alone, that we just get a d20 like normal. But if we provide something, then we try to parse that as a roll. And I think I handle that nicely. If you give it I mean, someone's going to try it by, don't just hold on for a second. Don't screw with it yet. The fun of having a publicly accessible endpoint. Okay, well, let's just try this. So we're going to trim off the slash, and then what we're going to do is, okay, let's get the path as this, and then if the path's length is 0, then I'll make the roll 1d20. And otherwise, I'll take the path. So basically here, if you provide a path, then it's going to not work. If we provide a path, then it's going to try to parse that as a roll. Otherwise, it's just going to just use the classic d20. So I added an extra semicolon, messing up Rust types because I'm talking. Let's try this, and we can get rid of the roll that we had before. So I can run wash build, and then what I can do is I can go back to the Wasm Cloud dashboard, and I can actually get rid of that actor. If anybody rolls right now, it's not going to work, and I can run it again. So Bailey, you want to try out my my fix real quick?
Yeah, so this is what I had before.
Mm-hmm.
Now, what is the change? Just like, what do you want? Is this what you're expecting? Something like this?
So you should have now, like if you're doing the query string, it'll probably default back to rolling a d20. Ooh. Um, but what should happen now is if you hit that endpoint and you do slash 1d30 or something, is that what's happening now?
Yeah. So like this in the comment.
Yeah. So, yeah, so I can try it
Hey.
on mine. So if you
So it's
do
working for me.
nice, then that seems pretty solid. There may not be all the error handling in there or anything, but we'll stick with this. Let's at least just go from here. So um, now I can actually get rid of a dependency, which is fun. I don't need this form URL encoded anymore. And I'm actually kind of curious if that made my actor smaller, maybe just a little bit. Cool. So we have the new version of the actor, right? So this one accepts the D20 a little bit differently. Um, I can go ahead and add in those things into Git, and then I can create a commit saying changed role parsing from query to path, something like that. So I'm not, I did actually do a minor version bump. So it is good Simber, but there aren't that many active users of Woodice. But I can push this up. I think I updated my README. I can push this up, and just in the process of doing that, just pushing the actor, if I go back to my Woodice, this will actually kick off a GitHub action to build and sign the actor with the latest tag. But I can also push a tag for 020. So do version 020 and changed parsing. Not going to worry about it too much. This is going to kick off the Rust build, push a tag for 0.2.0, and we can watch that. We can watch that like we watch paint dry, or we can move on to something else and kind of come back to this, which I think I will opt to do. But this is going to build my WebAssembly module, release a new version, and then I can deploy that here in a moment.
Okay, so takeaway, I guess, so far for me is I am able to use the Cosmonic platform to mess with Brooks on any given day. No, so
Yeah.
I'm able, while Brooks is developing, I'm able to access a wormhole and look at maybe what he's working on, but he's also able to use the exact same workflow that he's doing locally and deploy the exact same WASM module if he wanted to production, which is pretty powerful. And so you showed going from, I believe, 2 different architectures as well. Definitely 2 different operating systems, but I think even 2 different infrastructures. Yeah, let's zoom in. Okay. So the host architecture is the same in this case,
Yeah.
but I believe it would work if you used any other type of host architecture.
Exactly. Yeah, that's something that I kind of gloss over because I'm used to it now, which has poisoned me for a lot of different things. But WebAssembly, the fact that I'm compiling this Woodice application to WebAssembly means that I don't need to care where I end up running it. So on my local MacBook, I'm running the exact same 700K, binary from an ARM MacBook Pro to one of the AWS Graviton instances, which that's kind of a implementation detail like what we run on with Cosmonic, but Mac to Linux without worrying about anything, which even if your programming language or framework is fantastic at cross compiling, you still have to compile differently for different architectures or for different operating systems. Same with most of the time architectures. So I mentioned AWS Graviton. It's one of their new compute types, but it's efficient and costs less. And people who are running Docker containers for their application had to start bringing in BuildX workflows. And this is not to say that that this is necessarily wrong. We had to do it personally. We distribute Docker images for Wasm Cloud, so I know what had to happen for this. And it's a pain. Seg faults happen, setting up QEMU, whatever. Cross compiling is hard, and anything that we can do to remove that with WebAssembly just ends up making this a lot easier.
Yeah, I guess that's maybe the other takeaway is this is all using WASM Cloud, and now I think I understand the WASM part of the WASM Cloud. That's the component that you're distributing around. That's pretty
Yeah,
cool.
yeah,
So,
exactly.
what did you want to show next? This is already pretty awesome.
Yeah, I want to show a really fun thing. Let's go ahead and I'm going to get rid of this WebAssembly module that I'm running locally in favor of the version that I ran from GitHub. Again, all just because all just because Wasm Cloud thinks of these things as different entities right now, which is just the way that my development environment is set up. This is not the way that it normally works. I'm going to launch the kind of production ready, or however you like to call it, version of Wadice. And you should be able to hit that through Cool Bush, which we had before. Now, I launched that on my local machine. It's actually pretty cool that I'm clicking through the UI and I don't know where I'm launching things, and it doesn't really matter. But I'll save that soapbox for a different day. This is on my local, and this is in Cosmonic's cloud. And for someone who is looking to come to a platform as a service like Cosmonic and play around with our developer preview, which if you're tuning in new to the stream, we're accepting signups at get.cosmonic.com. That's great. But if you already have a significant investment into infrastructure, this may not work for you. You may be running containers in Kubernetes on AWS or on the Azure Kubernetes service, or you may be running on just a VM in like Oracle's cloud. People's infrastructure requirements are vastly different based on their own personal preference, the organization they work for, things like that. So I ran Cosmo up on my local machine. I'd love to show you what it looks like to run Cosmo up actually on any cloud. So let's do that. So I have a couple of instances already set up, and when I say instance, all I mean is a cloud virtual machine in various different clouds, namely one in AWS, one in Azure, and one in Oracle. I did mean it when I said Oracle's cloud. And I did some of these things for my recent WASM Day talk at KubeCon. But let's actually show what it looks like to launch a host or to launch compute that's connected to Cosmonic on a cloud. So I can SSH into my AWS box. And I actually don't have anything installed. I'm going to be following this from the start. So this is pretty fun. It's just like a vanilla Ubuntu VM. I'm going to copy the install command again from the documentation. So this will actually download and install Cosmo. I guess this is on an ARM machine. So, it's going to be the same architecture, but that's fine. And I can run Cosmo up. Now, I am going to attach a label to this just so that we can keep track of it. So I'll just add the cloud equals AWS label. This is nice. You can do kind of a taints and tolerations sort of thing if you're used to Kubernetes. But essentially, we can say, run this WebAssembly module on this cloud. And I'll show you an example of that. So we run Cosmo up. And notably, this is going through an SSH session, so it can't open my browser, which is fine. I can just copy this URL, paste it in my current session, and the device is logged in and authenticated. So that will go ahead and go through the process of, again, downloading credentials, NATs, and Wasm Cloud. And it happens a little too quickly. If you come back to Cosmonic, this is a host running on AWS. So I can take the Wadice WebAssembly module and run it on AWS. So if we run Brooks and Townsend Wadice 013, I can find a compute host that's running in a cloud with the label AWS. And so doing that, we can launch the actor there. And then everything it's actually the wrong one. everything on CoolBush, of course, continues to work. It's now kind of pseudo randomly load balancing between those two, and that's transparent to the user, just as it should be. It's what you would want. So just to, kind of check understanding there, I just added another cloud into our arsenal. So, we have a compute host in AWS so that even if my local MacBook closes, even if Cosmonic, my host goes down for whatever reason, or on a different cloud, the AWS one still continues to run. And so we technically kind of have two clouds running. So, talking about like a multi-cloud strategy, which many people have thoughts on. This is a regulatory requirement in some countries, so making this painless. I don't even know if we could fit running a multi-cloud Kubernetes architecture into a stream like in a day if Bailey asked me an hour ago to do it. So,
Well, I
Bailey, did
guess
you have?
I have many questions,
Yeah,
but
yeah,
I'll just start with the first one. If you did want to run this on Kubernetes, could you?
yeah, absolutely. We have things in our open source. We have a Helm chart in the Wasm Cloud host runtime repo, which I can actually get you the link if you like. Um, we have a Helm chart and a container that we distribute. So with the whole goal of um, people who are running cloud native apps today probably have a significant investment into Kubernetes now. And so we aim to be compatible with all of these technologies, but not dependent upon, oh, hey, there it is right there. Dependent upon them. So all these things that I'm showing you are not running in a container, not running in Kubernetes, but the process is the same. The whole end goal for us with Cosmonic is to have a Cosmonic Helm chart that you can apply, and that kind of connects into your cluster. But that's still kind of something that we're looking at prioritizing.
Very cool. Okay, so if I wanted to connect together all of the clouds, that's possible. I posted your YouTube or the YouTube link to your talk from KubeCon, where I felt like you did kind of wrangle all the clouds together, which is notably very difficult. Whenever I hear people talk about hybrid cloud, multi-cloud, usually they talk through the perils of trying to do something like that. All the different providers and provisioning. And so what was required for you to just put together that one in AWS? Is there another one that you can show off?
Yeah. And so in terms of doing this in AWS, I don't want you to get the impression that because I just kind of SSH'd into this box that I did a lot of pre-work. Actually, all that I really ended up doing was clicking through the AWS console and launching an EC2 instance, their Elastic Compute instance. So it's just a VM. So the same process that you would do anywhere else. I honestly just didn't want to work through it on stream because it takes time and nobody, I think, wants to see you click through the console. But the process for any cloud is the exact same as what I just showed for AWS. So I have an Azure compute VM that's running as well that I can kind of just sudo into. Again, I don't, oh wait, I might, yeah, I don't have Cosmonic installed on here. I can run the bash script to install. This is actually an x86 architecture, and I can run Cosmo up all the same to connect in Azure. So I can authenticate this cloud essentially. And then going back to my constellations page, this Azure box will kind of pop up here in just a moment. So, we're kind of extending this to Azure, and then I can do the same thing. I'm doing this in different tabs, but it's just a implementation detail. I can do the same thing in Oracle's cloud. I can try the same thing. Nope. I can run the bash script to install Cosmo. I mean, the reason why I'm doing this is so that you can see how flexible this is and how this could kind of be done in like a CI, like a user data or cloud init script. It's very, very simple. This device login can all be kind of, you can grab your credentials ahead of time if that's your use case. But then there's Oracle Cloud. So, this setup that kind of went through as we were just talking has now local MacBook, Cosmonics PaaS, the hosted platform, and then my own instances in Oracle, Azure, and AWS. And they're all ready for you to deploy your applications on. You know, the pain from doing this in terms of Kubernetes or containers is not necessarily the deploying the piece of your application there, because you could do the same thing. It's stitching it all together so that your application components can communicate across these different clouds. You can survive a failover event. So if I have this one dice actor running on my local machine and one running in AWS. And if I just completely get rid of the AWS host, simulate an outage, everything kind of works all the same. It automatically reroutes to available compute. And I know this is a lot. It's kind of hard to talk to the power of this, but it's really cool to see this working. You really just have to try it out for yourself.
Yeah, so I mean, so far I get that I don't need to worry about the host operating system or architecture because we're using a technology called WASM that is portable and independent of those aspects. Because it's a virtual machine, WASM is something that I've played around with for a while, so I'm familiar with that side of it. And the stitching you talked about in the beginning is coming from NATs. That part is really powerful, I think. But why would anybody want to do this?
Why would anybody want to run across different clouds or different machines or things?
Yeah.
Well, I think that there's two really big things that we kind of showed today. One, that your local development environment doesn't need to be totally separate from your production environment. So when everyone's on this stream, kind of poking at my live Wadice URL, you're watching me develop, and part of that is in the cloud, and part of that is in the environment that I'm most used to working on and iterating quickly. And so, I worked at a really large financial institution in the US. We had a huge investment into containers and Kubernetes. And sometimes, depending on what I was working on, my developer iteration loop was, write code locally, make sure container builds, push to GitHub, wait for CI to build container, and deploy to dev before I could see if my thing worked. And so, we don't want that. I don't think any developer wants that unless they just like wasting a lot of time. We want to be able to iterate on our local machine and have it work the same as it does in production. And that's how, I can kind of no fear push this WebAssembly module up and run it in different clouds because I know that it already works. So I think the first thing why anybody would want to do this seamless connection is because you can, your architecture can change over time. And second, running in multi-cloud isn't something that a lot of organizations do. It's not a thing that a lot of organizations do well. In some places, it's starting to become, it's in Europe, it's a regulatory requirement to have a multi-cloud strategy in case one cloud fully goes down. And so it's all in the name of your reliability and availability requirements for your application. Doing this, you may run in a truly resilient cloud native architecture. You'll run in different regions or different availability zones. But it has happened before where things like, I don't know, say you use, I'm going to pick on AWS, sorry. Say you use like Elasticache for all of your key value storage and Elasticache has an outage. Like that's not the same as running in different availability zones. You may need to fail over to a different cloud like backup, like somewhere in Azure. There are many different use cases for why, and a lot of it just comes down to the architecture of your application, I think.
Yeah, that all makes a ton of sense. I guess one of the things that I'm trying to figure out here is where is the edge? I'm not sure I can find it. uh,
Yeah, great.
seems like the whole thing is the cloud.
Yeah. And then this demo, I would kind of argue that the closest thing to the edge is my laptop. Edge is very nebulously defined. People use it in different usages. The way that I really see it, and the way some of us I think see it at Cosmonic is that the edge is just kind of a morphing term for like getting the compute as close to the data and the user as possible. And that requires to be ultimately requires your application to be massively flexible. So, you may think of a shipping company is going to want to run big workloads in the cloud and then smaller workloads maybe in their trucks or in their warehouses and have that all kind of connect, but process things locally when possible. Steve Schotler, he works for Cosmonic. He actually just did a demo at ARM Summit where he was doing dynamically routed machine learning models. So the use case for that is you can run really powerful machine learning inference, like translating or trying to figure out what's in a picture in the cloud on a GPU enabled instance. But then you can run really lightweight inference like on a Raspberry Pi, maybe connected to a camera that's trying to read license plates. Like I'm kind of spitting this example, from the hip, but hopefully this kind of illustrates like the edge use case is making what we have better. Like we're already pretty darn good at deploying a monolith to the cloud. Like that's been done. If you're trying to just do that, this can work. Other things work really well too. But deploying to really tiny devices that are close to the data is a huge edge idea. I kind of rattled a little bit. Did that answer what you were asking, Bailey?
Totally did. Totally did.
Okay.
Thank you.
Points that you're putting out there publicly. This is the only ingress point that you have into your private networking space. So we want to make sure that that can be secured if possible.
Well, Brooks, I had a blast. Is there anything else we meant to cover that we didn't hit?
I think we had some good
Oh,
questions and showed some cool things. Yeah.
I want to know what happened to your GitHub pipeline.
Oh yeah. Let's prevent GitHub from being slow. So we've actually built and signed that actor. It took about 4 minutes, which is a little slow, I would say. But if we check our releases, we have WDICE 020 available. So I'll go ahead and copy this URL. I didn't really mention this before, but you can see at a bird's eye view what every single WebAssembly module is going to do, which is cool because you know that this actor, even if you run it on your own machine, can never access your files, never access any databases or make HTTP requests. Very cool. This is all Wasm Cloud principles of deny by default that we kind of extend. So let's do a live upgrade. So the WDICE actor that we're running now is 0.1.3. And if I go in my URL, I know this is going to be small, but if I type, 1D 50, I'm only going to be rolling a D20. But I can actually just terminate this older version of the actor. I can run the newer one. I didn't actually even look where this is deploying to, so that's kind of fun. And if I refresh, I can now roll bigger things than a D20. So that is what happened. Where did I deploy that? Oh, MacBook. Okay, so it's on my local machine. That's fun. But I could deploy it anywhere. It doesn't matter.
If you wanted to deploy it again, can you do that and have it on a different host?
Yeah, absolutely. So when you deploy, you can choose a host. We have friendly host names, which it may be small, but you can kind of differentiate them easily. You can also do things like I showed before, where we find a host that's running in, say, Oracle Cloud, or we can run an instance in, say, Azure, or we can run multiple. Like we can run, I'll do 8 for a nice round number. But you can see the kind of scale of this individual actor here in the top right. For what it's worth, WebAssembly is super fast. and like it runs at near native speed for a more technical term. But the WebAssembly module itself, we run our entire platform on on WebAssembly and Wasm Cloud, and we've never needed even more than like 3 instances of each actor. So this is really set up for some high performance HTTP requests, and everything, of course, works all the same. No matter, there's no difference to the user about where things are running. There's also doesn't need to be a difference to the developer. So very cool.
Do you mind giving me a peek of the infrastructure view? I want to see if it shows where all those actors are deployed.
Yeah. So if I look, I've actually got one running on my local machine. I've got one running in Oracle, and then I actually should have them in Azure. I may have just like not quite updated yet, but they're running in Azure as well. And then the HTTP server is running in Cosmonic's infrastructure still.
So definitely multi-cloud. That's pretty cool.
Yep. Yep. Very
All
fun.
right. Well, I don't see any more questions. So I think it might be time to go. But it was super fun. I'm looking forward to what you have cooking for next time, which maybe will be in a couple weeks. What would you guess?
Yeah, let's I'd like to stream a little bit more. Let's do it maybe not next week, but definitely next couple of weeks. Sounds great.
Yeah, I'll try not to surprise you with it.
Yeah.
Any call to actions that we have?
Yeah, I'd love to do just one last call to action if you're interested in, what you saw today. Cosmonic.com has a sign up right up here in the top. All we're asking for is email and GitHub username, and we can get you added to the platform. And all of the documentation that I showed today is just available here under the docs section. So would love for you to try this kind of thing as well. Create your own applications. What Dice was born out of a fun thought, like, hey, what if I could roll a die as a WebAssembly module and make that available publicly? And it's fun to create your ideas in this way. It's nice and easy.
Very cool. Well, thank you so much, Brooks. Thank you, Internet. If you have ideas for things you want to see Brooks do live, please send them our way. I enjoy it probably just as much as everybody else does. So yeah, thank you for joining our stream.
Yeah, thanks everyone.